Our second task is called Genie and a Bottle. So you're walking along a beach and your toe hits something hard. You reach down and grab a handle and pull out a lamp, and boom, it's sandy. You start to brush it off with your towel, and poof, a genie appears. So he tells you, "Thank you for freeing me from the bottle. I was getting claustrophobic." You can choose one of these purses as a reward. So in purse A, you get $1,000 today. And if you leave it alone, it's going to contain 1,200 tomorrow. And the next day, it'll be 1,400. And you'll have $200 a day, and that will continue. Purse B will have 1 penny today. Then tomorrow, it's going to have 2 pennies. And then the next day, it's going to be 4 pennies. And it's going to double each day. So how much money will be in each purse after a week? So remember, a week is 7 days, and 2 weeks is going to be 14 days. Now, in looking at the first purse, this pattern is linear. So if we had to write an equation for that, we could say y is equal to, our starting value is $1,000, plus we add $200 per day. So I would multiply 200 times D. Now, similarly, with an exponential pattern, you've learned about exponential equations in 8th grade, but we would go y is equal to our starting value, 0.01, 1 penny, and then times our growth rate, which in this case, the pennies are doubling. So I'm going to put times 2 to the day. So this number 2 is our growth factor. Now, if we're going to look at how much will it be in each purse after a week, we would just plug in the numbers to our equation. So y would equal 1,000 plus 200 times 7. So you can do that by hand or with a calculator. Either is fine. So 1,000 plus 200 times 7 gives us $2,400. And that's after 7 days. So similarly, if I wanted to figure out after 2 weeks, we would put in here y equals 1,000 plus 200 times 14. And get 3,800. So there's quite a lot of money in the first purse. Now, in the second purse, we would go y equals 0.01 times 2 to the 7th. So to do that, I would definitely use a calculator. So 0.01 or 0.01 times 2, and then raising it to the 7th power. That's why these are called exponential functions. The variable is in the exponent. So we would have $1.28. So after 1 week, your purse only has $1.28, which so far that does not seem like a good deal. I for sure would want the other purse with $2,400. So we're going to check, well, how much is in there after 2 weeks? So we go 0.01 times 2 to the 14th power. So again, that's after 14 days, which is 2 weeks. So 0.01 times 2 to the 14th power. And the equation right now has $163.84. Again, that is much less than the $3,800. So now we're going to continue this for 3 weeks. Again, 3 weeks is 21 days. So to do purse A, we're just going to evaluate the function and go y is equal to 1,000 plus 200 times 21. We can compute that directly. And we get 5,200. And then for purse B, we would go y is equal to 0.01 times 2 to the 21. So here we have 0.01 times 2 to the 21st power, which if we're looking at this, we have $20,971.52. So obviously, all of a sudden, this became a much better deal. Purse B has way more money after purse A than purse A. But at first, it didn't. So what if you waited the full 30 days? So on here, for purse A, we would go y equals 1,000 plus 200 times 30. So here, 1,000 plus 200 times 30, which is $7,000. And then let's check out purse B. How much money would you have? So y would equal 0.01 times 2 to the 30th power. And this here, if I write all that out, I have 107,374.18.24. Putting in my commas, I would have $10,737,000 for $737,000, 418 and 24 cents. So $10,737,418.24. So purse B is obviously the much better deal. But let's talk about the parts of an exponential function. So an exponential function is of the form y equals a times b to the x power. And a is known as your initial value, or what you start with at time 0. And b is known as your growth factor. And a growth factor can be any number that's between 0, that's greater than 0, or higher. So we'll talk about how to make an exponential function grow or how to make it decay.